A very good evening, everyone. Am I audible to all? So, ending off for the class almost or the batch and see the strength. Okay. So, did any one of you went through the yesterday's lecture by any chance? Yes, no, anything?
About graph, yes.
Okay. So, after going through it, what anything, any question you have?
No.
No? Okay. Just give me a minute. I'll just. Okay, so yesterday I gave you guys the introduction about like what is a graph and what is a directed graph, what is a undirected graph, whether it is cyclic, whether it is acyclic, and etc. etc. Right? Everyone, are you getting me? Yes. Okay. So today we will see like how you can represent a graph. Basically, if I'm saying this, it means that how to store graph or how you will what should I say, traverse a graph or access a graph. Because tree we have seen, we create a separate class which has, let's suppose, left data, right data, and it has like left node, right node, and it has a data of its own. That is the tree structure. But in graph we never know like how many parts it is connected to, right? And which part is connected to what part, we don't have any clear idea. Are you guys getting it? So basically for that purpose, whenever you see some questions of graph, you are not given a graph actually in pictorial way. It is given like you have n, let's suppose you can say n vertices, and you have m edges. And if it is a weighted graph, the weight between the edges. So this is the way it is given. Are you getting it? Yes. Okay. So I'll just give you an example here. First, I'll give you the numbers, the number of. There are total 14 vertices and total 14 edges. Obviously, the weight is going to be the same. Then here, this is vertex 3, 4, 3. Just a minute. Yeah, and here M. Hmm.
Ma'am, I'm just wondering how it can have so many edges with that many points.
No, this is the point. Like basically from 4 to 8, there is an edge. From 3 to 10, there is an edge. From 11 to 13, there is an edge. Sorry.
Okay, 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 okay. Okay, got it.
Are you clear now?
Yes.
Is the screen is still visible to you guys? Okay, now it would be.
Yeah.
Like previously, was it shut off?
No, for me it was okay.
Okay. 2 and 9 and 9 and 5. Here you can give any number of weights you want, so like basically according to the question. So if you try to make the graph out of this, it will somewhere look like 4 to 8, 4, 8. Then you have 3 to 10, then you are having 11 to 13. Next is 4 to 14. Next is 4 to 10. Another one is 10 to 11. Then next one is 14 to 12. 4 to 1. Next is 3 to 6. 3 to 1. 1 to 12. 1 to 7. 1 to 9. Sorry, is it 1 or 2 to 9? 2 to 9. And next is 9 to 5. So this is how your graph will look like. Is it a connected graph or disconnected graph?
Disconnected.
Disconnected one, right? So you understood like how will be the format of the inputs given and how you have to like how the graph actually looks like.
Yeah.
Now the next is how to store it in our date. Like for tree, we used to store a class node, but here how we store actually the graph data, that is the next question. Okay. So we can either use an adjacency, not adjacency matrix, or you can use adjacency list. So adjacency matrix is what I'll discuss later, but what is adjacency list? I will tell you right now. Matrix is basically, I'll just show you here. Whatever number of nodes you have, right? So you will just make the matrix of that size only, that is n cross n or n cross m, like the number of nodes and edges. So here you can have, here it will be m, like the number of edges, here it will be n. Okay, so with 0, like let's suppose it is your first node. So with first node, whatever number of edges you have, like with 2 you have, with 3 you have, but wherever you have, you just make that particular matrix block as 1 and let the other blocks where there is no connection are there keep as 0. So whenever you are traversing in this matrix, you will know that okay, there exists a connection between 1 and 2 and there exists no connection between 1 and 1. Are you guys able to follow this? Yes, no. Okay. Now we will see adjacency list. Adjacency list is basically like you have a list and you know that it has indexing like 0, 1, 2, 3, 4, 5, 6. So every indexing I consider as a node. Okay. That is first node, second node, third node, fifth node, like that way. So here it is 0, 1, 2, 3, 4, 5, 6, and goes on. So here, if you have connection from, let's suppose, I'll show you the example. Let's suppose the here example says from 4 to 8, right? So what will you do? You will again make a list over here from 4 and you will store the first element as 10. Let's suppose the next connection is 12, so you will store 12. If there is like the weight associated with them, then you can make a list of pairs and comma, you can put the weight here. Are you guys getting it? This is the way you can store your graph in an adjacency list. Clear or not? Is it clear?
Ma'am, so it is a list within a list. Why I'm asking is
Yeah.
because within
Yeah.
4.
See, from 4, there can be many connections, right? So you need to have a list of list.
Okay.
Okay.
So within a list, list within a list, that each of the object will have two data. One is the
No, it's not compulsory because sometimes you have unweighted graph as well, right? So it
okay.
won't have two data. It will only have one data. But in case of it is a weighted graph, then it will have two data. So you can make list of pairs. That means you are storing two datas in like one place.
Okay.
Clear?
So in that case, it will be one data class with two variables, and that objects would be in the list and in another list. So okay,
Got it?
yeah, okay.
So I guess it's pretty much clear to you guys. And next is, I guess you can like initialize adjacency list and make two like list of list on your own, like initialize it. Can you do it? Yes,
So
no?
so initialize with -1 and then
Initialize it with -1, probably keep him in mind, like not necessary exactly why to initialize them as -1, because you are only collecting the data here which is necessary, right? You are attaching 4 with the data which is attached with 4 given in the input. You are not doing any unnecessary stuff though, so that you have to keep -1 and all. In here we have to keep 0 because you are making, like you are taking a huge space unnecessarily, and you are using only few connections to fill one. That's why we have some default values here. So if you see adjacency metrics, it is using your unnecessary space, like consuming your unnecessary space. 0 0 0 0, it's not needed when there is no connection between those two nodes. There is, it's not needed, right? In adjacency list, it's not taking any unnecessary space, hence it is more space efficient. Are you guys getting it?
So in both the cases, a null should be stored. That will be more efficient.
What null?
So if the point,
Why to store anything? By default it is null, right?
yeah, yeah, okay, okay. Yeah,
Mhm.
got it.
And next, make sure that you are creating a graph of length n plus 1 and not n. Okay, because edges will be from 1 to n, not from 0 to n minus 1. So just keep that in mind. Clear? Okay,
But it is,
perfect.
but it is starting from zero. So even though
It
it
is
is
starting from 0, I know, but you're just wasting one block, right? But in the question, whenever it will be given, it will be like from first node. No, it won't be from 0th node.
correct, correct, correct. Okay. Okay. So when I fill it, it will be from zero onwards. So it will be one minus whatever is the value.
I am not getting you. What are you
Oh,
saying?
no, no. So for example, in the given example, like there's a connection between 1 and 12, then we will actually be storing in adjacency list of 0 and 11.
Yeah, no. If there's a connection between 1 to 10, we will be storing it into 1 of 10 only. Why 11? I'm just saying that if you create an array of size n, it will only take you till the index of n minus 1, not n.
Yeah, yeah. Okay.
Are you clear?
Yeah, so since we are storing, so index 0 would correspond to 1. Yeah.
Okay, I'll show you. Here I'll just like make a random creation of graph or like basic graph. This is a program just to show you guys like how the code of graph looks like, so that you don't have any problem in taking the inputs for it. I just explained it to you. I'll write the code for the adjacency list and won't be writing for adjacency matrix because I'm expecting if I'm doing 1, you guys will be able to do 1 at least. So one thing is test cases as usual. Next is, guys, am I audible? Okay, perfect. So now you have to read the values of n and m. So I'll take n and m, you know that indexes and like nodes and vertices. So here it is gonna be, I'll just take for instance 6, and m also I will take it as 6. I'm not making it as an weighted graph as of now. I'll directly make an array list of array list. For graph, it's G. Why integer? Why not pair? Because since it's a not weighted graph, okay. If it is weighted, you could have take array list of integer. My Eclipse screen is visible, right? Okay. Then you have to loop till n. Sorry, my bad. Guys, are you clear so far with this? Now we will go on the edges and like one by one set our edges. So here it's like we have to read U, V, and W. So W is not there, but we have to read for int. Wait, I just. So you have to add at U position dot add and whatever your V is. Next, since it's not a directional graph, it's unidirectional, like non-directional graph. You will do vice versa as well. G dot get off V dot add U. Clear? Is it clear?
So you're making bi-directional graph by pointing U to V and V to U.
Exactly, because since direction is not given, you can move from U to V as well as V to U, right?
Okay.
If direction is not specified. Getting it?
Yes, ma'am.
Okay. Now, once like since we are done with this, now we will move towards how to traverse in a graph. Okay. So there are basically two types of traversal techniques in a graph. So one is BFS and the other one is DFS. So this is known as breadth first search, and this is known as depth first search. Clear, everyone? So in BFS, it's like that you travel breadth, like basically level by level. Okay. Like what I'm trying to say here is if this is your graph, yeah, let's suppose you have your top node as 14. So you will go to all of its connected components, that is 4 and 12. Here, I'll show. You went to 4. After 4, you will go to the remaining ones, that is, sorry, 14. You will go to 4 and 12. Then the connected components with 4 are 8, 10, and 1. So you will go to 8, 10, and 1. And with 12, it is 1 again and nothing remaining. Next is after this, you will go to 8. Nothing is there. After you will go to 10. You will get 11. You will get 3. Next is from 1, you will go to 3. It's there. Then you will go to 7. And from you can go to 6, from 7 nowhere. So these all are done. Are you getting it? There are still few more remaining, so you will start from 2. 2 is connected to 9, and then 9 is connected to 5. So basically it follows level by level. From top level, then it covers all the numbers in the next level, then another level, and then it goes this way. That's why it is known as breadth first search. Clear? Clear or not? Questions on this?
So one thing came to my mind was like, eh, how do we find that we are approaching from one common element from both the sides? Like for example, there was a point where three was adjacent to both via 12
See,
as well as.
there are certain nodes in your graph, right? So whenever you have a node like 1,
Ma'am, we can't hear you.
hello, hello,
Yeah, now we can hear. But 2 minutes ago, it was choppy.
hello, everyone.
Yes, ma'am, we can hear you now.
So what I'm trying to say, for every node, like to notice if it has been already done or like it has been visited or not, we maintain a visited Boolean array, which is initially all is set to false. One by one, when you visit a specific node, you make that like the index for that specific node as true. Clear? And that way you can know that, okay, this is specific node is covered or that specific node is not covered. Make sense?
Yeah.
Okay. So I'll just show you here. NNM, you have been given 14. So this is NNM basically given to you. Then What follows is U and V. Okay, don't confuse it with like nodes, and this is U and V after comes. Basically, it's like hidden. And what are U and V? They are like node comes from U, it ends at V. These are the data given to you if you have to form the adjacency list. So Vishnu, you had in doubt that okay, it will be in whatever your n is, it will be n minus one or something. So basically what I meant to say, if it is 4, it is exactly getting stored in the place of 4, right? But if you have made an array of n minus 1 size, then this 14 block would not have been here. So the place where 12 and 14 needs to be stored, you will not be able to store that. Are you getting this? Because your particular array would have been of size 13. That is n minus 1 starting from 0. Make sense?
Yeah, so I mean, again, so zero should be blank. Um,
Yeah, it will be blank, obviously.
yeah, then I'm fine. Yeah, good.
See, from 4 to 8, it is making the connection, and then you have to make from 8 to 4. Then 3 to 10. Then you have to make from 10 to 3. Similarly, 11 to 13, 13 to 11, 10 to 4. Like it's not a hierarchy, okay? It's just a comma, but I'm just writing it in a hierarchical way. 4 to 10, 2 to 9, then 14 to 4, 1 to 4, 4 to 1, 12 to 14, 14 to 12, 1 to 7, 7 to 1. Next is 6 to 3, 3 to 6, 5 to 9, 9 to 5, 1 to 12, 12 to 1, 3 to 1, 1 to 3. All this is filled up, and now we have to do the BFS. Right now, would you guys like to do it on your own first? Like, how can you traverse on like using the BFS and all? Will you like to try that on your own first? Only one person responding in the class, and that is Vishnu. Fourth index. 4 is related to 10 if you can see in UV. So 8 is written. Then somewhere it is written 10 is related to 4. So I have written 10 is related to 4 as well as 4 is related to 10. Like we are doing it both ways, from U to V as well as from V to U. Are you able to follow this?
Yes, ma'am.
Okay. And that's way how it is designed. Yes, guys. So will you like to do it on your own?
So all we are doing is just to store and then traverse.
This is I have stored already. I've written the code in front of you in Eclipse, right? That
Yeah.
was this only. This will be the output of that. So I want you to do the BFS, write the code for that, and like how you are gonna traverse every node and then come back to me. Clear?
I'm just trying to understand, like, from any node, like let's say start from 4, we will do just move next, next, and then mark it as visited, visited, visited.
Oh,
Uh,
correct. You have to take a visited array of n size.
one thing I have wanted to ask, like, uh, we have to keep on printing also, like from one
Yeah,
point.
it's your choice now that whatever you are was like popping out, you either you want to print it or you want to like store it somewhere. Anything you want to do, you can do it with that. You have done the level order traversal for trees, yes or no?
Yeah.
Try to follow that approach, right? And that we used to do. No, we used to store root node, then like in a queue, and then push the remaining nodes. Then like pop the root node, keep the remaining nodes, then again pop the existing node, push the child nodes for that. Remember that?
Yeah.
Yeah, try to do it in that way. At least try it. If it's not possible, then obviously we will discuss that in the class. Okay. So
Okay.
tomorrow we will discuss that.
Okay.
Friday I can't have the class. So Friday, like you guys can plan it in advance that the class is not there, whatever you guys want to do. And by Monday, I will try to finish all the questions of the graph. And then I guess bitwise manipulation. So probably I will finish it in the next week. 1 week I will keep for miscellaneous questions and the questions I wanted to discuss with you, but it's like it was meant for bit maturity. So I will discuss that at the end. Clear?
Ma'am, try, yes.
Sorry?
There is some topic you said, TRIES, try,
Yeah,
yes.
I said no. There are some topics which needed more maturity, so I will discuss that. Okay.
Okay. Okay.
Okay. So I'll just stop for today, and I will join with you guys tomorrow. Bye bye.